A record-breaking cable car is being built on Germany's highest peak. This is precision work at an elevation of 3,000 meters. At 127 meters, its steelwork pylon is also a record breaker. The old pylons are being taken out of commission. The new cable car will climb an unrivaled 1,945 meters. The Zugspitze, Germany's highest mountain. Setting up the crane is the first step in the construction project. At an elevation of nearly 3,000 meters, the strong wind, lack of space, and steep precipice all pose a challenge. A team of experts is preparing to assemble the rotating tower crane. It can withstand wind speeds of up to 280 kilometers an hour. A special helicopter brings the components up to the peak. It's the only option under these conditions. A Swiss specialist company has taken on the mission. The pilot and his ground crew are an experienced team. Essential for a job as tricky as this. The helicopter is a Russian Kamov Ka-32. Sporting more than 4,400 horsepower, it has a lifting capacity of 5 tons. The heaviest crane component weighs 3.5 tons. The assembly crew battle the wind from the rotor as they carry out the precision work. The helicopter transports all 25 components to the peak at one time. The weather on the Zugspitze is fickle, so the assembly work has to be carried out as quickly as possible. First comes the cabin. Next comes the boom. The pilot has to bring the enormous steel component into perfect position. The crane has been specially configured for work on the Zugspitze. The tip of the crane is now the highest point in Germany, 2,975 meters above sea level. It's tight quarters up here. That's why the northern section of the planned summit station will project 35 meters above the precipice. The immense forces exerted on the structure will need to be shifted to the rear. That will be accomplished by the so-called tieback structure. Before the concrete can be poured for the suspension cable towers, an area has to be cleared. A crew carries out targeted blasts to make room for the towers that will eventually anchor the suspension cables. The boulders plummet down the mountain and shatter into small pieces along the way. Without a material cableway, a construction project like this would never get off the ground. Along with the crane, it's key to the logistics chain. 300 meters above the valley station, there's a staging area for the material needed at the peak. Concrete, steel girders, glass facades, insulation, tools, and machinery. The material cableway was specially built for the project. It can transport 5 tons of material per trip. taking 12 minutes to travel 3.5 kilometers. Once at the summit, the crane takes over and moves the load to the construction site. It's a challenging task for the crane operator, who also has the changeable weather to contend with.
With large surfaces, this is a mid-sized one, and strong wind, it's very dangerous, of course. You have to pay attention and compensate for it if need be. It varies. That's 2.8 tons of glass, and its surface area is not an issue. But with a lighter load, just a few hundred kilos, it's very dangerous. You have to pay attention, compensate for it. When you're lifting something that's fragile, you need to make sure you don't bump into anything or let the wind slam it into anything, like the scaffolding. That's a risk.
But wind and weather aren't the only obstacles. The construction site is crowded and there's little overview. That's why the teams steer the crane via remote control. The crowded site is another challenge at Germany's highest construction site, as is the fact that the summit will remain open to visitors for the duration of the project.
They've got tons of questions. It's nice, and we crane operators enjoy answering them. Sometimes we have to put a stop to it, but we always do our best. We try to give the visitors a feel for what we're doing.
The new mega cableway on Germany's highest peak will replace the venerable Ypres cable car. It can no longer handle the large number of visitors. So after more than 50 years in operation, it will go into retirement. The summit station will also feature an enormous new observation platform and a glass-walled building. The cable car will set 3 world records: a 127-meter steel aerial tramway tower, a free-span ropeway of 3.2 kilometers, and a one-section height difference of 1,945 meters. The new building will consume more than 1,000 tons of steel and 1,500 cubic meters of concrete. When it's done, the facade surface will clock in at 2,000 square meters. Ambitious goals for a construction site that's short on storage space. Jochen Rohrmoser is the site manager.
Servus, jetzt Ihr Heideier zeigen.
Are you bringing your stuff down today, or will you be back tomorrow?
That's definitely coming with us.
Ja.
Unseren Handrist und was mit der Kiste, weil wir müssen wegen der Treppen können wir auch noch mehr runter.
When will the second handrail be here?
Anlauf, wann kommt der?
Der Durchfahrt
Today's Thursday.
ist Donnerstag.
Normally it'd be here Tuesday.
Good.
A tight schedule and a crowded site. To make sure they're ready by the launch date, several companies are working here at the same time. And then there's the throngs of tourists to contend with.
Wenn zwischen 1,500 und 2,000 Leute sind,
When there are between 1,500 and 2,000 people here, it does get very crowded.
10 bis 12
We've got about 10 to 12 different groups working up here. Each one needs a spot to put their material.
Baustelle mit 4 LKWs vor die
In
Baustelle.
a construction site in the valley, I can drive up with 4 trucks, unload them, and everyone has their stuff. Here it all comes by crane. So of course it takes more time. That's the logistical balancing act we're dealing with up here.
Den, wo wir da heroben so treiben.
When it comes to transportation, the Zugspitze has a long history. The first cogwheel railway opened here in 1929. In 1962, the cable car up the Zugspitze was built. A milestone of technology. Before that, the only cable car was a short one along the final stretch up the summit. The Austrian plan to build a longer aerial tramway on the other side of the Zugspitze helped spark Bavaria's ambitions. And the cable car built in 1962 lived up to its promise. At 65 and 86 meters, its aerial lift pylons broke the world record. The summit station was a feat of engineering. The cable car had room for 44 people. Over its years in operation, it transported more than 21 million visitors up and down the peak. But the old cable car couldn't keep up with the Zugspitze's popularity. It's the end of an era. 7 months before the planned opening, the old Zugspitze aerial tramway takes one last round of guests to the summit. And then, after 54 years in operation, it hangs up its boots. Over the next months, it will be dismantled. Even the 2 pylons are slated for removal. But not right away. They're needed for the construction of the cable car's successor. At the summit, change is also underway. The defunct cable car structure is dismantled to make room for the new and much larger summit station. The crew removes the old entryways and the roof coverings with the help of blowtorches and the construction crane. The weather takes a turn for the worse, leaving the crew to do battle with the wind, snow, and freezing temperatures. Suspended by a cable, the old steel roof is dismantled into smaller pieces. The debris will later be brought down into the valley by the material cableway. In the valley, work is also in full swing. The demolition equipment is operating at full throttle. The old structures are no longer needed, and they're dismantled with brute force. The past and the future lie virtually side by side. Just a few meters away, the new valley station is nearly finished. The next milestone is imminent. The new cable is being delivered, a special cable made in Switzerland. It's come a long way and still has a long way ahead of it. The new cable car will use 4 suspension cables. Each one is 4,900 meters long and weighs 153 tons. A single cable takes 2 trucks to transport, its weight carefully distributed by logistics specialists. The 2 trucks are connected by a rigid axle. Without this workaround, hauling the suspension cables would require a much larger heavy load vehicle, too large to navigate these roads. Under pouring rain, the convoy winds its way through small towns and across the countryside. The valuable freight reaches Gainau in the middle of the night. The next morning, it's time to unload. That's easier said than done, given the size of the suspension cables.
What's special is that it's a very thick and strong cable, 72 millimeters in diameter with a minimum braking force of nearly 700 tons. Those are quite remarkable statistics.
Over the next months, the construction crew will transport the 4 suspension cables, called track ropes, up the mountainside, anchoring them at the summit and in the valley. Each of the new cable cars will travel along 2 track ropes. The cabin is propelled with the so-called haul rope.
This is an important step for us in the schedule. Now that the track ropes are here, we can begin assembly. The old cables of the old cableway will act as midwives. They'll help hoist the new cables up, which will make the entire process much easier.
At the same time, countless trucks loaded with steel are making their way up the mountainside. There's another construction site at 1,285 meters elevation. This is where the new cableway's only pylon tower is under construction. Another crane is here on site. To operate the cable car with only a single pylon, the new one will have to be stronger, bigger, and higher than its predecessor. At 127 meters, this is the world's highest aerial tramway tower of its kind. The pylon contains more than 9,000 screws and 1,100 individual parts. More than 18 truckloads of steel went into building this 420-ton behemoth. "11 specialists are assembling the enormous tower. It's work that requires a clear head at great heights. Soon, the cable cars will pass underneath. The distance between the summit station and the pylon tower is 3.2 kilometers, another world record. Once it's finished, the cable cars will speed past the tower at nearly 40 kilometers an hour. The saddle of the enormous tower will have to bear more than 100 tons of weight. The tower is now ready for a final coat of paint. And the saddle. The saddle will hold the aerial tramway's track ropes and haul rope. A special crane brings it into position. But the construction crane isn't tall enough or sturdy enough to hoist the 22-ton saddle to a height of 127 meters. Instead, it's raised using a winch and pulley system. The winch is hanging at the top of the tower. The crew is getting ready to hoist the saddle into position. Meter for meter, the saddle is winched into the assembly position. The crew makes sure the huge saddle doesn't bump into the tower. Now they're at the final stretch. The crew attach smaller cables, which will allow them to carefully ease the 22-ton structure into position. It's a tricky maneuver that requires strength, skill, and above all, a clear head for heights. The next phase of construction will take place on the steep, snowy cliff face. It's another challenging mission for the cable car specialists. The guide pulleys will be mounted at an elevation of more than 2,000 meters. The guide pulleys ensure that the new cables won't be damaged by the cliff face on their way up the mountainside. Whenever a new cable is pulled up to the summit, the crew keep watch by the guide pulleys and make sure that the cable isn't damaged en route. The experts carefully bring the huge guide pulleys into position. The location they're working at today is a precarious one. It's nothing for weak nerves. The guide pulleys are in position. Now, the new suspension cable can be hoisted into place. The launch date is 3 months away. Time to bring the first track rope to the summit. It's a daunting task. The crew will use the old Zugspitze tramway cable to pull the new cable up the mountainside. First, the two cables need to be joined together. This spot will be subjected to extreme forces, so the connecting element needs to be very sturdy. The crew will cast a bushing around the steel cables. But first, Chief Assembly Technician Harry Reich opens the new track rope using a special technique. The track rope is comprised of many smaller steel cables. Each one has to be bent out. That will help bond the casting compound and allow the cable to withstand the tensile force it will be subjected to. The cables are still covered in grease, which is removed using a special solution. The exposed cable is pulled into the sleeve. The casting compound is heated. It melts into liquid, and then it's poured. The old track rope is now joined to the new one. The bushing has both a right and left-handed thread. As soon as the connection is tightened into place, the cables are ready to begin their journey. The first few meters go without a hitch. But then the cable gets snarled in the trees. The two cables separate.
Might separate all the way.
The two cables have to be reconnected. It's an unexpected delay. The crew use an extension lever to tighten the thread. This time, the connection has to be solid.
All right, 3 more centimeters. Now we're at 7. 1 more. All right. Okay, it's secure. We're done. Now we're ready to start up again. First, we tighten it with the snatch pulley until we reach the linear pulley. Then we quickly pull it through the linear pulley. Then we tighten the clamp and continue with the linear pulley. Okay, go ahead.
The linear pulley takes over and hauls the track rope up the mountainside. The new cable car is a reversible aerial tramway. When one of the two cabins is heading up the mountain, the other heads down. There are 3 cables in each direction. The 2 upper cables are the track ropes. They remain stationary, and the cabin's wheels roll along them. The haul rope is underneath. The haul rope moves the gondola as it travels between the valley and summit station. The cabin moving down the mountainside pulls the other one up. The haul rope, which is nearly 9 kilometers long, is propelled by 2 electric motors located in the valley station. But the motors aren't operational yet. That's why the linear pulley is doing the hauling.
It operates with 2 clamps. One is pulling now. While it pulls, the other retracts and grabs the rope. So it's operating in parallel, which means the rope never stands still. As one clamp opens, the other one returns. So this pulley system will keep hauling the rope up to 40 hours until it reaches the summit.
The linear pulley continues to operate through the rest of the night. The next morning, its work is done. The 153-ton rope is at the top of the Zugspitze. But this is just the first stage. The crew will have to pull another 300 meters of rope into the summit station. There's not much room to maneuver. It's freezing, and the air is thin at the summit. It will take several pulleys to hoist the rope into the station. 2 crew members are on the cliff face, monitoring the new cable. The huge diverter pulley was installed here especially for moving the rope. Later, the track rope will be wound onto this winch. A heavy-duty 20-ton winch is brought into service.
This is the winch where it starts. Then it passes through the big 20-ton pulley up over there. Here it switches to the middle of the cable track. Then it goes back over a 10-ton pulley, then down on the side here, passing over the small pulleys, ending up in the pulley block. The problem is there's no room. We have to navigate these very tight quarters with all of these pulleys. That makes it all quite a bit trickier, and we have to keep a sharp eye on things.
While the main pulley moves the track rope upwards, several smaller pulleys ensure that it doesn't get caught on anything. It's a major technological challenge, and the work can't be rushed. The tramway construction crew are masters of their craft. With a job this complicated, they have to be. Communication between the various team members is key. The crew members at the pulleys up top can't see where the rope is. That makes giving clear feedback and instructions all the more important.
The section that's loose has to be pulled up with a small pulley. I have to monitor when he needs to continue because he's pulling it at a different speed. I need to tell him when to tighten the winch so that the rope doesn't drag too much. He needs to be fully focused 100%. When he tells me he's ready, I need to be able to rely on that. And he needs to be able to rely on me when I say it's time to pull. So we both need to be able to rely on each other's instructions or it won't work. All right, Michi. We'll start tightening it. Got it.
The cable pulleys are set in motion. The block and tackle then starts to pull the heavy track rope upwards, meter for meter. The crew watch the operation with eagle eyes. Slowly, they hoist the cable to the summit station. Finally, the connecting sleeve appears, along with the track rope.
Now we'll cut off the bushing that we used to pull it up. It has to be welded together properly to make sure that none of the smaller cables shift out of position. Otherwise, the track rope could split open. That's why we have to clamp everything well using several clamps, which we'll tighten. Then we'll cut the cable and weld the front together.
The bushing is cut off with a huge metal saw. The interior of the track rope contains another special cable. The 4,900-meter track rope will carry the cable car, but it also has another job to do.
There's a fiber optic cable inside that will later be used to transmit all the computer data.
The crew now welds together the end of the track rope. The weld seam and several clamps that have been screwed into place hold the smaller cables inside the track rope into place. Once it's welded shut, it needs to stay that way. Another crew member welds an eyelet onto the rope. That will make it easier to wind up again. When it's finished, this wood cladding will be carrying 180 tons.
Wood has the best friction coefficient, so we'll wind this around it 4 or 5 times. And this is a very special kind of wood with a specially good friction coefficient. Now with wood, we won't have to clamp the end as tightly. We could use plastic or steel, but the friction coefficient would be much smaller. And then we'd have to wind this around it more often.
300 meters of track rope are now wound onto the spool. It will also serve as a reserve.
Yep. 100 meters will be wound onto this to secure it. It will be wound onto the wood and clamped over there. That will secure all 180 tons. We need to keep 200 meters in reserve because every 12 years, the longest saddle edge needs to be moved. Then we need to let it down by 33 meters and tighten it back up again. Then the leftover part gets cut off, and that happens every 12 years.
Winding 300 meters into position takes time. The crew can only wind 100 meters a day. The first track rope is now in place. There are still 3 more to go. Two months before the planned launch date, it's time for one of the landmarks of the old Zugspitze aerial tramway to leave the stage. This 85-meter tower will be retired today. The crew come with blowtorches. At the top of the tower, other team members are already dismantling some of the smaller steel parts. The crew start dismantling the base. To make sure the huge tower tips over in the proper direction, the crew mount a steel cable to the tip and fasten it into place. Later, targeted blasts will destroy the remaining connecting parts, and the tower will topple toward the rope.
First, we span the cable all the way at the top, which is where we'll have the most force. Down here, we'll set up a winch and pulley so that we can apply between 40 and 50 tons of force.
The preparations are complete. Now comes the blast.
When you use a winch, it's almost like chopping down a tree. We can't chop down the tower, of course, but using a winch gives you much the same effect.
The 400-ton Colossus doesn't fall exactly where it was supposed to.
It was a bit tricky due to the tower's position and its wide base. That made it harder to tip it exactly where we planned, but we got close. You can't predict it perfectly because the weight is distributed on two legs of the tower. If one breaks, the tower falls in a slightly different direction than planned. That's why sending the tower in the direction you want is harder than it might seem.
Now it's time to mount the rope supports to the new track rope. The rope supports fasten the track and the haul rope together and help prevent oscillation along the cable path. The crew have to travel all the way up to the summit on the auxiliary gondola. The 21 rope supports are fastened to the ropes at varying intervals. They also keep the ropes from getting tangled and prevent the haul rope from sagging during operation.
The full length is 4.5 kilometers. The supports are fastened every 180 meters to 230 meters along the entire route. We vary the distances so that the rope won't start to oscillate. When you put a weight on at irregular intervals, that prevents any oscillation.
The cable winches in the valley help pull the auxiliary gondola to the summit. Each rope support is fastened to the track rope in 4 places.
That gives you the V shape with the pulley in the center. The haul rope will bounce up from the pulley during transit. When there's wind, that could cause the rope to shift to the side. So there are also guideways that automatically bring the rope back to the center of the pulley. It's insulated so the rope doesn't touch the steel. We're under a bit of time pressure because tomorrow we'll have bad weather. But I think we'll finish today.
The crew spend the entire day working at this dizzying height, mounting one rope support after the next. It's precision work. The small generator hauls up one rope support after the next. The weather's cooperating, and it looks like they'll finish today. The auxiliary gondola passes by the new record-breaking tower. It's meanwhile been painted. The sun is slowly moving behind the summit. As dusk falls, the auxiliary gondola reaches the summit. The last rope support is fixed into position. And the job is done. When the next day dawns, all the rope supports are in perfect position. The 2 running gears have arrived in the valley. The cabins will be fastened to them. Each one has 24 wheels, which will drive on the track ropes. A mobile crane carefully lifts the running gears from the flatbed truck. Each steel structure is comprised of a hanger and running gear, weighing 7 tons in all. They have to be mounted with great care to ensure that the track rope isn't damaged. Chief Assembly Technician Harry Reich keeps a sharp eye on the process. The only thing that's missing now are the 2 cabins. 3 weeks later, the big day has arrived. It's pouring rain, but the first cabin is ready to mount. The crew position the cabin beneath the track rope. With a rope winch, they'll pull the running gear into position. But first, the auxiliary gondola and its running gear has to be removed.
We'll bring the auxiliary running gear down, which we use to transport the ropes. Then we'll move the new running gear into the same position. We'll slip the cabin into it and use the 4 Habegger jacks and hand pumps to pull them up. Then they'll be mounted on the chain.
It's a job that requires full concentration. The crane operator brings the new cabin into position, taking care that the valuable gondola isn't damaged. The ground is uneven here. The crew uses pallets to create a level surface.
Like this? That's all right. Now we'll pull the running gear out over the cabin. Then we'll pull it up with the 4 Habegger jacks and mount the chain.
The cable winches on the ground lift the running gear up from the station. The crew attach straps to the cabin, which will be used to lift it. The 4 fixing points are ready to go. The crane lifts the cabin the first meter. Then hoists take over lifting the valuable cargo.
It weighs about 5 tons. It's a challenge. You don't want to damage something so high-tech. We want to bring it safely and securely onto the hangar.
The crew work with care and precision. With help of the hoists, they move the cabin into position. It has to be perfect, down to the last millimeter. This isn't the kind of job a crane can handle. The cabin would start to swing and make it impossible to fixate the bolts.
We have to work with precision. Every millimeter counts. We can't do this with the crane, so it takes all 4 of us.
The cabin is in position. Now the crew start mounting the bolts. Between cleaning, applying grease, and mounting the bolts, it all takes longer than expected. And it's still raining, making for challenging conditions. Next, the straps that were attached to the cabin have to be removed. But one of the knots is stubborn.
Well, with the rain, it all took a little bit longer. But in the end, it worked.
The cabin is finally in place and starts slowly returning to the station.
Hang on. I need to make sure we have room.
The width of the entryway hasn't been set yet, and as it turns out, it's not wide enough.
Sepp. Sepp isn't replying.
Sepp.
I'll have to go over. There's no reply.
The assembly crew isn't replying, and the cabin can't stay in this position overnight. It's a minor mishap, but it has to be fixed. The Bavarian Zugspitze railway crew haven't left for the day. They'll help Harry Reich bring the cabin to its safety position. The central platform in the valley station is movable. Reich tries to shift it a few centimeters. That might be enough to make room for the cabin. But it doesn't work. They'll have to find another solution.
It's still too narrow. I'll release the screws and push the wood back.
The side rails aren't in their final position yet, so they can still be shifted a few centimeters. That should create enough space for the cabin. The side rail is several meters long. Moving it turns out to be easier said than done.
I'll have to get the hammer. Yeah, guess I will.
Time for the hammer. But after just a few moments, the chief technician realizes there's another problem.
Yeah, that's as far as it will go. Take a look.
The left side is their last hope. They're running out of time. It's getting dark.
We can't leave it outside. That position isn't bad, but if a storm comes, it might sway and hit the sides.
All the screws have been loosened, but the side rail isn't cooperating. Now it's time for brute force.
That's given us a bit of room. It's working.
A few more blows of the hammer.
Okay, now release it slowly.
The crew carefully let the cabin glide into the station. Success.
It all worked. Given the weather, we weren't sure we'd manage it, but it worked. We widened it and got it in. We're actually about 20 centimeters too far in the station. Later, we'll have an electric train stop there. We're right at the limit, the buffer.
The cabin is safely in its berth. On the summit, the 3-year construction project has also borne fruit. A spacious and modern structure made of glass and steel graces the mountaintop. On December 21st, 2017, the new Zugspitze cable car celebrates its grand opening. A masterpiece of engineering and a testament to the dedication of the entire crew.
It's a wonderful feeling, the chance to take part in the world's biggest aerial tramway. It all worked out, and I'm really pleased that it's done and working perfectly.
The floor-to-ceiling glazing on the Zugspitze cable cars offers a spectacular view. The windows are heated, providing unobstructed visibility, even in bad weather. The new cable car on Germany's highest peak has it all, including 3 world records: the tallest aerial tramway tower, the longest free-span ropeway, and the largest one-section height difference in the world. A masterpiece of technology at an elevation of nearly 3,000 meters.